Eigrp WAN consideration. In this video, I'm going to talk about some topics related to the WAN. We can call all of them WAN consideration, for example. Okay, first let me to talk about the first feature. We call it the bandwidth percentage. This is one of the useful features that we have in the Eigrp. First, let me to talk about this feature. After that, we can talk about another feature related to the, for example, WAN consideration. You know that here we have one simple scenario. Assume that R1 connected to the R2 with one WAN link. Here, for example, we have 1 megabit per second. Okay, and also you know that beside of the WAN, also we have here one LAN interface. For example, here we have 1 gigabit interface in the router 1 and also in the router 2. And you know that we are sending some traffics, okay, from the WAN link from the router 1 to the router 2 and also from the router 2 to the router 1. Actually, this is the real data, okay? We are sending the real data from the, for example, LAN, some part of traffic, not all traffic, okay? And then from R1 to the R2, okay? Also, beside of the data of the users, okay, we have some control plane traffic. For example, the routing updates. You know that if you enable one routing protocol here, for example, RIP, Eigrp, OSPF, ISIS, or another protocol such as the BGP, okay, we are informing to neighbor that we have connectivity to which network. For example, look at here. Assume that here we are R1 connected to the 10.110/24, and you know that if we enable, for example, Eigrp or some other routing protocols, the R1 should inform this network with the routing, okay, protocol update to the router 2. Okay, this is the default behavior. Okay, and after that, when sending this routing protocol update, the router 2 inform about the availability of 10.110, and after that, for example, the router 2 can send the data to the destination of this network to the router 1. For example, here we have one packet, destination is 10.110, okay, and this packet now is receiving it by the router 2. Router 2 can forward it to the router 1 and then to the from the router 1 to the destination network. Actually, we have two types of traffic on one WAN interface or on one WAN link. Okay, these two types of traffic include the control traffic, okay, control traffic such as the routing updates, okay, or control plane traffic, and also we have data traffic. Okay, you know that we should advertise the control plane traffic such as the routing update traffic for example, informing to the other routers, and after that, with the control plane traffic usage, we can send the data, real data from the R1 to the R2. This is the behavior. Actually, the bandwidth of this link should be consumed for routing update, okay, means control plane traffic, and also data traffic, both of them. You know it. But now let me to inform you about functionality of some protocols. For example, let me to talk about the RIP. You know that RIP, or routing information protocol, is one of the weakest routing protocol that we have today in the world. And actually in most networks, we don't use the RIP or routing information protocol, okay? If you enable RIP, for example, RIP version 2 in one network, this is possible that the routing protocol consume all of the bandwidth of the links. This means that, assume that here in R1 we have many routes. For example, we have 1,000 subnets. Assume that in R1 routing table we have 1,000 subnets or maybe more. And also here we are using a link with a lower bandwidth, for example, 64 kilobit per second or 128 kilobit per second, 512 kilobit per second, and a little more, a little less. Okay, actually, when you are sending the routing protocol update from the R1 to R2 in RIP, this can consume all of the bandwidth of the link, and this is not so good. Why? Because when you are consuming all bandwidth of the link, the R2 cannot send the traffic to from this link to the R1, and also R1 cannot send data traffic to the R2. Actually, we shouldn't, okay, consume all of the bandwidth of one WAN link for the traffic of routing protocols. This is important consideration, okay? In the EIGRP, we can control it, but in the RIP by default is using all of the bandwidth. For example, when you are enabling the EIGRP, by default, EIGRP allows only, EIGRP is allowed only to consuming maximum 50% of the bandwidth of the link. Actually, this means that assume that the bandwidth of link is 1 megabit per second, and because of that, EIGRP can consume maximum up to the 500 kilobit per second of the bandwidth for its update. You know that. If we have more update, okay, we need to send them in the next second. In each second, you can send 50 kilo, for example, bit. 50,000 bit or 500 kilobit or 500,000 bit or 500 kilobit. Okay, this means that EIGRP allows only using the, for example, 50% of the bandwidth of the link. You can reduce this value, and also you can increase this value. Actually, here we are talking about the bandwidth percentage of the link. One of the features that we have in the EIGRP is controlling the maximum amount of bandwidth that the EIGRP can use for sending the routing updates, and we shouldn't increase the bandwidth percentage of the link. In some cases, we are reducing the bandwidth percentage usage of the link for the EIGRP, because beside of EIGRP, we have another protocols and also the real data. Because of that, we shouldn't increase the usage of the bandwidth with the EIGRP. How we can control the percentage of the for example, bandwidth usage for EIGRP? It is so easy. In the traditional configuration, in classic configuration, we should configure this feature on one interface. Why? Because in each difference, we have the different amount of bandwidth, and maybe we want to configure different percentage in each interface. Because of that, for example, in the traditional configuration, classic configuration, we are configuring interface name, and then IP bandwidth percent for EIGRP AS number, for example, AS1 percentage, 50% or 30% or so, or some other values. I will show you. After that, in the named configuration, okay, again, we should go to the router EIGRP name, address family, IPv4 unicast, autonomous system AS number, and then on one interface, or maybe you want to configure this on all interface. AF interface name, or AF interface default. Here you should use only the bandwidth percent command, percentage. That's it. And also with the show IP EIGRP interface detail, then the name of interface, we can verify the bandwidth percentage. Let me to configure this feature, and after that we can better understand the configuration. And you know that about the bandwidth percentage, in most cases, we don't increase the usage of the bandwidth for the EIGRP, and maybe in some cases when we have one link with lower bandwidth, for example 64 kilobit per second, it is recommended to, for example, decreasing the EIGRP usage of the bandwidth. Let me to show you one simple scenario to learning about the bandwidth percentage configuration. You know that this is one of the EIGRP WAN consideration tools that we can use it. Okay, here we have one simple scenario, router 1 connected to the router 2 with one serial interface. Let me to show you the configuration of router 1, conf-t interface, okay, serial 10. The IP address of this interface is 10.1.2.1.255.255.2.550 and no shutdown. Okay, this is the configuration of the router 1, host name is router 1. Let me to configure the router 1 with EIGRP in the traditional method router, EIGRP1, okay, then network statement, network 10.1.2.1 quad 0. That's it. This is the configuration of R1. Let me to configure the router 2, conf-t, then interface serial 10, IP address is 10.1.2.2, okay, 10.1.2.2.55.2.550, and then no shutdown. After that, router EIGRP in ENARSI. Here I'm going to configure the EIGRP with the named method, router EIGRP ENARSI, address family IPv4 unicast AS number 1. Then look at here, network 10.122 quad 0. Now we will have one neighborship between the router 1 and also the router 2. This is the router 2, host name router 2. Okay, let me to show you the neighborship. In R1, show IP Eigrp neighbors. We have neighborship with the router 2, and also in the router 2, show IP Eigrp neighbors, and after that, as you can